This is the screencast for section 4.2, example 1. We're going to look at the mean value theorem. The mean value theorem for derivatives says that if a function is continuous at every point in this closed interval a to b and differentiable everywhere in that point between a and b, there is at least one point in that interval, we'll call it c, where the derivative at c equals the average rate of change, or the slope, from the beginning to end of the interval. So for example, look at this first picture here. We start at a and b and find the slope there. Let's call that slope, I don't know, 2, fine. Well then, the derivative at c is also 2, so the tangent line would be parallel to the chord connecting a and b. Now if the graph is not differentiable at some point, that could be the point where you would be expecting that the derivative to equal the average rate of change. So see, the slope between a and b here is 0. You would be expecting the slope of 0 down here if this were a parabola or something, but because it's not differentiable, we've got a corner there, there wouldn't be, the mean value theorem doesn't exist. F prime of 0 does not equal the slope from a to b. And then if it's not continuous, same thing, we could have a slope here of, I don't know, well, I guess it's 1. And then here the slope is 0. Nowhere is the derivative of our actual function going to equal a slope of 1. So let's look at an actual problem. Show the function f of x equals x squared satisfies the hypothesis of the mean value theorem on the interval 0 to 2. Alright, so to show something satisfies the hypothesis, you have to show both restrictions of the hypothesis. So you have to show that x squared is both continuous and differentiable on its domain, or in between 0 and 2. And since f of x squared is a polynomial, it does satisfy both of those restrictions, or qualifications. Then we have to find the solution c to the equation on this interval. Alright, so this point here at the beginning is 0, 0. The point here at the end is 2 comma 2 squared, which would be 4. So I can find that slope. I also know the derivative of f of x. So I'm going to say the derivative is 2x, and that's going to equal the slope connecting these 2 points, which I know is 2. And then I get the x value to be 1. So this point right here, 1 comma 1, is where the derivative equals the slope across the entire interval from a to b. The now try problem number 1 says, state whether or not the function satisfies the hypothesis of the mean value theorem on the given interval, and if it does, find each value of c in the interval a, b that satisfies the equation. So f of x does satisfy the mean value theorem because f of x is a polynomial, which are continuous and differentiable. So b, we're going to find where f prime of c equals the slope from 0 to 1. So I'm looking for where 2x plus 2, the derivative, equals the slope of the 2 points on the ends of the interval, 0 comma negative 1 and 1 comma 2. And I get that the x value 1/2 is where that occurs. So here at the x value 1/2, the slope equals 3, which is the same as the slope connecting the outside points of this interval.